This video, we're going to be tackling the LeetCode question, maximum subarray. And as usual, let's go ahead, hop right into it, and let's start off simple. So the whole entire point and what LeetCode wants from this question can be derived from the title. The title in this one is actually very telling, maximum. You're a computer programmer, I'm not going to explain maximum. Subarray. Subarray may be a little bit more confusing to some people, but a subarray in LeetCode terms is this, a non-empty sequence, which is total gobbledygook HR speak for a piece of an array. That's all that a subarray is. This is a subarray, this is a subarray, this is a subarray, this is a subarray. And whichever numbers add up to be the largest subarray in this problem is going to be the answer. And in our case, I'm just going to go ahead and give you the answer 4, -1, 2, and 1 adds up to 6. This is the largest sum. That's exactly what they want. Now, key point, they want the sum. They don't want the length. They don't want another array. All they want is the sum, and that makes our lives infinitely easier. So let's just say in some crazy alternate universe, you have to solve this problem without a computer. You have to solve this problem just by looking at it, by hand basically. Well, any sane person is just going to look at all of the possible combinations. You would have to go through every single combination one by one and just see what adds up to be the largest number. So we would have to do something like this. We would go to 2, we go 1, 3, and just calculate every single individual possible sum out of this subarray. And as you can imagine, this would take a long time for a human, and it would also take a lot of time for a computer. The way that we would solve this problem with a computer is basically we would just make a nested for loop. A nested for loop would quickly just go over all these sums and calculate every single possible combination, but this has a serious drawback. It's quadratic runtime. It's slow for a human, it's slow for a computer. Not only that, but we can't solve this problem with a sliding window because the numbers are negative. If you looked at the title and you saw the words maximum subarray, you probably were thinking sliding window, but remember that negative numbers don't work with sliding window. So what do? We have to use what's called Kadane's algorithm. And it sounds confusing, and a lot of these niche algorithms are really stupid, but this one is a good introduction into the world of dynamic programming. And what exactly is dynamic programming? Dynamic programming is a fancy phrase for, hey, don't calculate everything. If you don't need to calculate half of these sums, don't calculate the ones that have literally zero possibility of becoming a maximum sum. Only calculate things that even have the possibility of becoming the answer. But how exactly do we know that? Well, we know this from the LeetCode constraints. The LeetCode constraints tell us that the sum is going to be positive, and Kadane's algorithm specifically is built around this concept of whenever you're calculating the sum cannot be negative. What exactly do I mean by that? Kadane's algorithm is built on a single for loop. You don't have to have any other pointers. You don't have to have any while loops. It's literally just a single for loop that's going to iterate through every single value. And we're just going to start at the very first value, which is -2. -2 is a negative number, so we're going to go ahead and zero it out. Just think of it as every single time we see a negative sum, we're just going to go ahead and zero. So 1 is a non-negative number. We're going to go ahead and leave it. Then we're going to try and add 3 to the 1. This is going to equal -2. -2 is a negative number. We're going to go ahead and zero, and so on and so on. And that is literally the whole entire algorithm. So let's go ahead, let's hop over into VS Code and let's code this thing up. So the first thing that I'm going to do is I'm going to create a brand new class, and I'm going to call this solution. You could put this anywhere, but I'm going to put it in the same folder where the main file is at. I'm just going to call it solution. Next thing is we're going to start typing out the method for the LeetCode problem. Now we have public int. Remember that we're not returning an array, we're just returning a simple int, and that's all that we need. Our lives would be 100 times harder if we had to return an array, but in our case, we can get away with just the sum. We're going to be taking in an integer array of nums, but you probably already knew that. Next thing, We don't have a queue. We don't have a hash map. The only thing that we need to calculate is the sum. So next thing, we're going to have max sum, and we need to grab the first element in the array, because if we just put 0 here, you may be tempted to just put 0 here, but if this number is -1, it's going to return 0, and it's going to cause test cases to fail. Next thing is we're going to have the current sum, but we can make the current sum 0 in our case. Why do we have two integers? Why can't we just have one sum? Well, we have two pieces of state here, because every single time we iterate, and we're actually about to start iterating here, every single time we iterate, if we just had this stored as one single piece of state or one single integer, every single time we iterate, it's going to reset it. Or if we come across a negative number, it's going to reset it. So we have to keep them in two different pieces in memory. So next thing that we have, we're going to have the current sum. And this is the piece of code that's going to reset if the current sum is 0. So anytime that we're calculating and we get a 0, we need to set this to a negative number. And this is the piece of code that I keep talking about that is going to do the reset if it's a negative number. This is the negative number reset. Next thing that we need to do is we need to calculate the current sum. If we've reset it, we've automatically discounted all of the possible sums that are negative. Now we can actually add this sum. But we can't stop there. Every single time we do this for loop, we're going to be calculating the current sum, but we need to keep track of the maximum sum. So after we get done going through every single possible value, we need to house the maximum sum. And how exactly are we going to do that? Well, we're going to do this with the math.max method. And what this method is going to do is through every single iteration, it is going to be comparing them and keeping track of that maximum sum. And after every single iteration and every single comparison, it's going to keep the maximum sum stored up here. So by the time we get done with the whole entire thing, we're going to have the biggest number. And after we get done doing all of the iterations and we get through the whole entire for loop, we are going to return the maximum sum. So let's go ahead and here, I'm just going to take this code and let's go ahead, toss it in LeetCode and see what we get. So we're going to go ahead, go into LeetCode. We're going to go ahead, put that in the actual code editor. Let's run it, see what we get. All of our test cases are accepted. Let's go ahead, hit that submit button, see our time complexity. Our time complexity, let's see here, is going to be N. Congratulations. And our space complexity is going to be 1. That is an amazing algorithm. We have passed the interview. Anyways, I hope that you guys enjoyed this. If you did, smash that like button, smash that subscribe button. As always, thank you for watching.